All right, everybody, welcome to Earth Science. We've made it to the next unit, which is going to deal with some complicated stuff. We've got to deal with the solar system itself. We're leaving behind the origin of the universe and the nature of the solar systems being in galaxies, and we're really going to focus in on the nitty gritty of what goes on with the solar system and how it causes all of this stuff, which might be a little intimidating and scary. And if so, you're thinking right, because this is probably the hardest section of the whole entire course that we got to do. But it's an important one. I mean, like look at everything that we're going to cover here, and as we really get rocking on this, it's going to lead right into why we have weather, really, because how does the sun hit the planet? How does that heat us, or not heat us as much in other places? You know, some places get hotter, some places get cooler. The air adjusts to compensate for that, and we get weather. So it's going to all flow together, but we've got a pretty significant bridge to cross to get there. Um, but you guys are going to do great. We can do this. All right. If the last unit was tough for you, and if that last test was tough for you, it's probably going to be a time where you got to consider some changes in habits. Um, you know, what are you doing in class? What are you doing outside of class? What maybe are you doing 10th period? How can we improve this? And I know sometimes it's just opening of the year jitters, but um, this is really where we got to accelerate effort-wise if we're gonna make it here. So here's what I want you to do. Why do we have all this stuff? I want you to hit, in a moment, press pause. I want you to guess on, say, three of those. Any three, all right? Why do we have those three things? Hint, hint, it really is all in this diagram. Press pause now and guess. I'll press pause too. Oh, so slowly. All right, so we're back. We're unpausing. At this point, you should have three of those filled in, telling me why you think we have those. And we'll come back to this at the end and see how you looked. Now, don't be scared by that stuff I said, but do understand that this is going to be some trickier stuff. But cool at the same time. How do the orbits of these planets give us all of these different effects? Um, Revolution versus rotation is going to be an important one. Maybe depending on what you guessed over here, we're going to have to really be focused on keeping in mind that revolution is a trip around the sun and rotation is a trip around our axis, one spin on our axis. Okay. On top of all that, why am I stuck on the surface of this planet? Why can't I, when I jump, I just keep on going? In the same vein, why doesn't the Earth just fly away if it's moving so fast? This thing's hauling. We're going to figure out exactly how fast, matter of fact, it's hauling. Why doesn't it just go flinging away? I bet you know the answer to that one already. Also, what are the shape of the orbits here? And what is the scale here? Is this like about what it looks like if I got into a spaceship and spent, I don't know, at this distance, probably 60, 70 years getting away from the planet to turn around and look at it like this? Is that to scale? Is that what it really looks like? Or are these sizes mixed up a little bit? Also, what shape are those? Boy, they look like kind of circular here because this drawing is a little bit pitched, but what really is the shape of an orbit? That's likely going to be the first line we do is what likely is the shape of that orbit. So yeah, it's a lot to unpack. It's an intimidating amount, and especially when we get to the seasons thing. I don't know if you made a guess here or not, but when we really get into the nitty gritty of that, it's going to get rough. Um, this is a cool. I should put the link on here too. I'll put it in the survival guide. This is a cool visual capitalist infographic on what does it really look like out there. And this is not to scale, hint, hint, but how much stuff is really floating around in our solar system. Where's my zoom? Do I have zoom? Over here. And if you go to it on the web link, again, that'll be on the survival guide. I'll put it there. You can zoom in. Now, like the other unit, no memorization here. We're not going to have you memorizing like any of this stuff. But the basic solar system data reference table, we'll still need to use that and think about what's going on here. As well as, we mentioned this quickly, if you were here on the equinox, in fact, I'm going to write that word in here and I'd ask you to join me. All of these photos are of an equinox. EQUINOX. If you're here the day of the equinox, I think I did it right on the day. We mentioned that Woods Road as it crosses, well, it's Route 41 on this side, and then as you cross 11, it turns into Woods Road going into the school. Right around the day of the equinox, the sun is like right in your eyes because the sun is rising exactly due east. And so that's what both of these photos are. This is me at home with my son around sunset on the same day. This is also an equinox, And our road also is pretty close to east-west, so we could have the sun set right at the end of our road being due west. I'm going to have you doing stuff like that. You are going to go onto Google Earth through this unit, not right now. You're going to go onto Google Earth, look at a map of your house, start to orient where north, south, east, and west are, and go home and try to like line up where these things should be happening. So these are all equinox, and maybe we'll just mention all types so it's neater. That the opposite, well, I don't want to say opposite, 3 months later is the solstice. For the two equinoxes pretty much work the same. You know, one's coming out of winter and one's coming out of summer, so there's definitely a difference in how we feel, but like astronomically, they pretty much work the same. The two solstices are going to be different. So 3 months after one equinox will be a winter solstice, 3 months after another equinox will be a summer solstice, and we'll keep on talking about those. If you've noticed, if you come in Route 41, the sunrise is creeping to the to the south now. So it'll be for the next for the week after the equinox, it would have been already like behind these trees, and it'll be creeping down this way, this way, this way, this way, this way, until 3 months later when we get to the winter solstice, and then it'll spend the next 3 months creeping its way back. And 6 months from this equinox, we'll be talking about the same situation again, where the sun is back to almost due east, and you guys will be Earth Science pros in all of this by then. All right, have those two down so I can just check, make sure you made it through this video. Welcome to our next units. It's a bit of a doozy, but you're going to do a great job. Hang in there, and we'll get the assignments rolling. Good luck, folks.